Welcome to the Mechatronics Revolution Fundamentals and Core Concepts. In this lesson, we'll talk in detail about the MSP432 microcontroller. The learning objectives of this lesson are to review the key specifications of the MSP432, explain the process of programming and executing code on a microcontroller, identify various components of the MSP432 documentation that will be important throughout this course, and then demonstrate a first microcontroller program on the MSP432 Launchpad. We have several robots here, and one of the things they have in common are that they both use the MSP432 microcontroller. As you can see, the MSP432 is a fairly high-end microcontroller that allows us to do things like sensor processing and filtering, or driving servos. And so, in this course, we're going to learn how to use the MSP432 and other microcontrollers like it to build interesting and useful robots and mechatronic devices. The MSP432 specifications are listed in this slide. The clock rate of the MSP432 is configurable up to 48 megahertz. There's 64 kilobytes of RAM, 256 kilobytes of flash memory, and the design of the MSP432 emphasizes compactness, low cost, and low power. It's interesting to compare the MSP432 specifications to something like the processor used on a laptop computer. For instance, the Intel Core i5 processor used on this Lenovo laptop has a much higher clock rate of 2.4 gigahertz, 8 gigabytes of RAM rather than 64 kilobytes, 300 gigabytes of solid-state non-volatile storage, and the emphasis in the Intel processor design for this laptop computer is more on low latency and calculation, so fast calculation rather than, for instance, low cost and low power, which is typically the emphasis for microcontrollers. Microcontrollers contain general purpose input and output pins. These GPIO pins are used to interface with external devices such as sensors or servos. On development kits or evaluation modules, these pins are exposed as headers, or sometimes they're tied to buttons or LEDs on the evaluation module for prototyping purposes. When looking at a development kit or an evaluation module, we typically see a lot of header pins. What do all these pins do? Well, the documentation for the microcontroller provides the answer. Many pins on the MSP432 serve multiple possible purposes. And this diagram provided by Texas Instruments shows the pin functionality for various input-output pins that are exposed on the header on the MSP432. The pin functionality can be configured between one of possible options during program execution, and we'll talk more about how to do that in the coming lessons. Shields or booster packs are typically available for a lot of microcontroller development kits, and these types of shields allow easy integration between the microcontroller development kit and other types of peripherals, for instance, sensors or motors. One of the nice parts about these shields is that they fit directly on top of the development kit, and so you don't have to run wires to connect, for instance, sensors or motor controllers to the microcontroller. Here's a couple of examples of booster packs, and these are a type of shield that fit on top of the MSP432 and are available from TI. Let's talk about how microcontrollers actually execute code. As soon as the microcontroller boots up, it looks in flash memory for the program that it's supposed to execute. So the first, initially when the board powers on, it takes the first instruction of the program that you provide in flash memory and it begins to execute it. So your program executes automatically every time your microcontroller starts up. Furthermore, your program continues to run until the board is powered off. So unlike a typical computer, the microcontroller doesn't run other background programs or processes. It actually doesn't do anything except the program that you tell it to run. When programming a microcontroller, you can't write code directly on the microcontroller like you would do on a computer. On a computer, oftentimes we draft the code in some sort of text editor, we might compile it, and then run it all on that computer. On a microcontroller, we typically have to write the actual code on a computer and then use some other type of device to place that program in the microcontroller flash memory. So to program a microcontroller, we'll have to connect the microcontroller itself to some type of external programmer. Here's an example of an external programming device available from TI that's designed to program the MSP432. Oftentimes these programmers can be expensive and are standalone devices that a typical prototyping operation doesn't necessarily have. The nice part about development kits or evaluation modules is typically you don't need to have this external programmer, but rather the microcontroller development kit has an onboard programmer on the actual device. So that means that you can use this development kit and program it directly from a computer rather than needing that external programmer. The MSP432 Launchpad has what's called an onboard programmer, onboard emulator, seen at the top of this diagram. The purpose of that onboard emulator is to provide a USB connection to your computer and to allow you to program the microcontroller chip, the little black chip there, directly from your computer. Furthermore, the onboard emulator allows you to actually debug operation of your microcontroller program also directly from your laptop. The final purpose of this onboard emulator is to provide power to the microcontroller from your laptop. So this onboard emulator serves a lot of different purposes and makes it very easy to test out programs and execute programs during prototyping. Let's talk about the two different modes that microcontrollers typically operate in. The first mode is programming mode. And what we're showing on this diagram here is that the microcontroller has both a flash memory bank and an arithmetic and logic unit, which is part of the CPU. So those two blocks are shown there. Now in programming mode, we have an external programmer, which can also be that onboard emulator for development kit. That external programmer writes data, or writes your program directly to the flash memory, and the CPU, or the arithmetic and logic unit, isn't really doing anything. It's essentially sitting idle, waiting for that program to be loaded. So that's what happens in programming mode. Now when you reboot the microcontroller, it operates in what's called the normal operating mode. Then, as we mentioned before, the first thing that happens is the arithmetic and logic unit, or the CPU, goes and gets its first instruction from flash memory, it executes that instruction, then it fetches the next instruction, and so on through this loop during normal operation. It's important to understand how to power the microcontroller. The MSP432 can be powered when installed on the Launchpad development kit via the USB interface with a computer. The MSP432 is powered via a 3.3 volt jumper connection, which is shown in red in this diagram. One key aspect of this diagram is that block in green. There's a little green rectangle that denotes what's called the isolation block. And this isolation block includes a group of jumper wires that really connect the onboard emulator with the microcontroller between those two dashed blocks on top and on bottom. The red jumpers are what connect power from the onboard emulator, or the computer, to the microcontroller. So when those red jumpers are installed, the microcontroller can be powered directly from the computer. When those jumpers are removed, the microcontroller needs to be powered externally, for instance from a battery or a power supply. To power the microcontroller, MSP432, from an external source, such as a battery or power supply, we'll have to remove these two red jumpers and provide a 3.3 volt input to the header pin marked J1.1, and we'll also have to make sure to ground the jumper pin labeled J3.22 to an appropriate ground, whether that's the battery or whether that's the power supply. The last important thing I want to mention about the MSP432 is documentation. It's very important to reference the documentation when we're developing programs for the microcontroller and designing our mechatronic devices. The MSP432 has 4 major components of the documentation. The first one on the left is the Launchpad User's Guide, and this provides the technical specifications associated with the development kit itself. So the red board to include the onboard emulator and so on. Second from the left is the MSP432 datasheet. This datasheet provides technical details of the actual MSP432 chip itself, so the black integrated circuit. And this will show, for instance, the pin diagrams of the MSP432 and so on. Second from the right is the MSP432 Technical Reference Manual. This reference manual holds the details of the MSP432 registers, the configurations, and is the primary reference manual we'll use when programming, and there's a lot of information in it. Finally, the last element of documentation on the far right is the Driver Library User's Guide, and this talks about the driver library programming interface, the API. This documents all of the driver library functions, and we'll talk more about the driver library functions as we get into programming the MSP432. To summarize what we've learned in this lesson, first, programming a microcontroller requires a dedicated programmer, which is for development kits or evaluation modules, oftentimes on board the circuit board itself, and allows us to program a microcontroller from our computer. But in general, programming an actual microcontroller integrated circuit requires a dedicated programmer. Microcontrollers do not run an operating system like a computer, but rather they only perform the instructions that are specified by the programmer. Finally, regular reference to documentation is necessary and is a key part of developing software for microcontrollers for any mechatronic device that we want to build.